Hello guys, good morning.
Oh, good morning, sir.
Okay, so can we start?
Yes, sir.
Okay, so give me a moment, please. Okay, so let me share my screen. So let's work on the services that I have given the document, right? Like cluster IP and the node port, load balance and external name. Okay, let me share my screen. Okay, able to see my screen? I have just shared my screen.
Yes, indeed.
Okay.
Yes.
Okay, so let's work on the services that we have to create some of the services in the Kubernetes, which is cluster IP and the node port. And let's explore on how do we create and how do we check the logs and where do we fix and how we're gonna create in the current namespace, right? And switch between the namespaces, right? Let's increase the font change. 18. Okay, then okay. So how do we check the context? How do we check the context that you're in which namespace? Nobody
kubectl
knows.
get ns.
kubectl get ns will list the namespace.
Get ns hyphen all. Will list all the namespace with their ports.
kubectl config view many5 namespace. Okay. Now let me list the namespaces. kubectl get ns. Now let's switch to the dev namespace because so as I said, we should be have the dedicated namespaces to be create our resources, right? And we will not use any default namespaces. We will be having the customized namespaces. Okay, and the namespace I'm gonna point it here as dev. Now the context is changed. Now when I run this mini5, now the namespace is switched to default, from default to dev, correct? Let's create the resources here. You're getting what I'm trying to say here. Okay, now pod and deployments that we created. Now let's create the services, right? So now currently we're in dev namespace. Let's create the services as a cluster IP, right? So how do we create? Okay, give me a moment, please. Okay, so let's start with creating a services which is cluster IP. Okay, so keep in mind the default service in your Kubernetes cluster, which is your cluster IP. Okay, and the second one which I explained, the node port. The node port range between 30,000 to 32,000. I forgot to inform you guys. So default IP in the cluster, which is cluster IP, the default services. So if you are not provided any service as a type cluster IP, it will create it as default. Okay. See, I have given here already. It is a default service in Kubernetes. Default service in the sense, in case of type cluster IP, if you're not given also, it will create the cluster IP default because it will create internally within the cluster, right? And the node port range. Okay. So I have node port range from 30,000 to 30,000 to 32,000. Okay, so we'll have to provide the node port range between 30,000 to 32,000. You need to remember this. This is very important. Okay,
32,767.
the specific number you can point, but the exact number we don't want here. You want 767.
Yes.
Okay. Now 30,000 to 32,000 approximately we will keep as a normal discussion. When you are in a project discussion, we'll say 30,000 to 32,000 as a node port range. In between this only we gonna point node port in our YAML configuration, specifically 32,700 something. That depends on your networking part and the team. If they opened any of the port apart from 32,000, like 600, 700, and also the 402, that they need to validate that they need to keep it open a port in the Kubernetes network. So the average, the port range from 30,000 to 32,000, that you can point it here. Okay, now let's create the service here. Okay, now I'm gonna create vi service dot yaml. So always remember, all the Kubernetes services are any of the component that you are going to create, which is in terms of YAML only, YAML. And there is one more format, .yml, that that we're gonna make use in the GitLab CI. Okay, so there are some difference in YAML and YML. Okay, so when you are using any GitLab configuration file, it will be in a YML format, GitLab CI. Okay, now let's create it. Okay, I'm gonna start insert. Okay, the very first letter, which is API version. API version v1, right? And kind as service, correct? So we're gonna create kind as service, right? And the third one, metadata, right? So under metadata, I'm gonna give here, let's keep it as my cluster IP service. So I'll keep it as the service name as my service, my cluster IP, sorry. Let's keep it as my cluster IP service. Okay, so this comes under metadata. Let's go to the spec. The fourth parameter is spec, right? So under spec, I'm gonna give here selectors. Okay, so under selectors, I'm gonna give it as app. Okay, so under app, I'm gonna give my app to select. Okay, and I'm gonna give it as ports here. Okay, so under ports, I'm gonna write protocol, which is which protocol that you wanted to use. Okay, so protocol TCP So I'll just provide protocol TCP and the port range. I'm gonna point it as 80, and then target port. Target port I'm gonna write here is 8080. Okay, and the type 8080. Okay, and the type I'm gonna give here is cluster IP. Type cluster IP. Okay, cluster IP. So this is how the configuration of the service of YAML file. Okay, so no worries on this. All the services that whatever we are learning, all together we will create it in a single package called Helm charts. Okay, so I'm going to explain over there, but here we are learning individually the pod creation, deployment creation, and the services, namespaces, creating namespaces, switch between the namespaces. All these activities we will create it in a single package called Helm charts. Okay, I'm going to explain that. Before that, we should learn this independently. Okay, one by one, each services we should learn, right? So that is the reason. So I'm giving it here. Let's save this. Just a minute. Okay, let's save this and let's create a service, right? Now, if I do ls, okay, I'm able to see service.yaml. Let's check the permission. Okay, now, so how do we create the service? kubectl
Apply
apply
hy-
-f
YAML file.
service.yaml, right?
Yeah.
Now, if I run this unknown field service.yml service in version v1 cannot okay, handled as a service. Okay, let's check the service again. Okay, API version v1 kind service metadata name my cluster IP service spec select. Okay, selectors. It is not the selectors, it is selector. The selector. See, when you type, no, this will be the problem. So, app, my app, and the ports. Okay, and it is in a YAML format. See, wherever you create a module under ports, suppose if you want to define any ports related to the YAML file, you will have to use this way. That's what protocol TCP, and then port 8080 and the target port. Here the second letter should be capital wherever you use in Kubernetes component. Target port is 8080 and the type is cluster IP. See here also we use first letter C in uppercase and IP is in uppercase, right? So that's how we use here also in the very first line API version, right? So this is how we have to maintain the syntax properly. Let's save this. Looks good to me. Let's kubectl apply -f service.yaml. Okay, now okay, service is created, right? My cluster IP service is created, right? Now, how do we check the service is created? kubectl
Get
get
SVC.
svc, or you can use service. You can use as a short command, which is svc. Okay, now our cluster IP is created. Under name, we would have written at service.yaml. Okay, now the name I have created and it's created as my cluster IP service, and the type which is cluster IP. Cluster IP. See, this is the IP which gives inside the cluster. This is assigned by the node. Always remember, whatever the services that you create, each service will have their own IP, and this is created assigned by the node. from the Kubernetes cluster, right? And how do we know this? This will create from the Kubernetes node, which is from the Minikube currently, right? So as I said, Minikube is the default cluster which is provided from the Kubernetes community. And the external IP is empty because external IP will not get in the type cluster IP, because as I said, cluster IP is the default service in Kubernetes which exposes the services, okay, on an internal IP. This makes the service accessible within the cluster. Means this will be accessible, this will be available in within the cluster, right? So it will not be exposed to the internet. That's why we use the cluster IP. We will expose it the very first application internally in the cluster itself, and we would be able to access the application, and then we'll implement in the application to be accessible from outside the cluster. Because when you implement your application, you will have to see it in web, right? That's how we do make use of services in Kubernetes. Okay. Now, how do we check the service log? So, as I said, to list all the services which you created in your namespace, right? How do we check? Mini5. Okay. So we are in dev namespace. In the dev namespace, we do have the service called cluster IP. Okay. How do we get the wide range of output? Okay. So I have given the command here, right? Here I have given some of the commands. Okay. Now kubectl get svc -o wide, right? Let's run this command. Kubectl get svc -o wide, right? So this gives the output in a wide range. See, okay. Here I'm gonna run one more command. Just get svc. Okay. So here you can see the difference, right? So this output and this output. So why do we use when do we use -o wide? Means here you will see selector, right? Means a selectors and labels, right? So I'll explain selectors and label in further sessions. Currently, see, selector, I'm defining it for app is equal to my app, right? Here app means whatever the selector that you have given in your YAML, it will tag to the particular name in the dev namespace, in your particular namespace, so that we are controlling our pod, we are controlling our services by tagging a name, by providing a name called selector, which is app is equal to my app. Means this is my application, right? So inside this, I do have inside the service as type, I have my application here. We are tagging it some name called app colon my app, right? So it will pick as a selector here. Means it is a kind of a label, selectors and labels. We are providing it. We are tagging it. That is the reason we will tag each and every resource by providing a name called labels in Kubernetes. We are grouping some uh, resources. Okay. That's why we use when you're debugging your services, when you're debugging your pod, we use to print output in wide range. Similarly, if I run kubectl get pods, okay, so here I do have a pod created, which is this, right? Now, if I run kubectl get pods -o wide, right? So here you can see the difference in the output, right? Only when you run get pods, and you will see the output -o wide along with the get pods, right? So when you point -o, the output represent -o represents output in wide. Means this will gives your, okay, this will gives your name readiness gates, Okay, so are you able to see the readiness gates here in the first command? No, right? It is pointing currently no, none, right? The readiness gates. Okay, and the ready 1/1. Okay, and the status is running, restarts every 4 or every 3 seconds. It will restart, and the age till year is correct, right? Now we were getting rest 3 parameter are extra from -o wide command. It will give the IP. So how do we get to know the pod will have the IP? We'll have to use -o wide. When you run only, you will get the IP address of your pod. See, each and every pod will have their own IP address, own network. That's what I'm saying here. Okay. So these pods are created from the deployment that we created, right? See, when you deploy deployment only, these three are created, correct? 3 or 4? 4, right? Now these 4 are having different IP address, correct? See, the range is same. See, the very first two are same, which is assigned from the node. 10.244 is default in all the IP address. You should observe this, right? And only the last digit is different, right? 31, 32, 29, 27. 28 is missing here. Why? Because remember that we have deleted one pod to check whether it will create automatically or not. Correct? Correct, right? Okay,
Yes,
28
sir.
is here. 28 is here. 28, 27, 28, 29, 30 is missing, right? And we'll have to, suppose if you delete this pod, it will recreate automatically. That's why 30 was missing. Then it assigns the another IP from the node from your Kubernetes cluster automatically in the Kubernetes networking part. It will assign it immediately. Okay. So this you need to make sure that when you're debugging, start debugging your pods, start debugging your deployments, your service. Okay. This you need to understand clearly. Okay. So from this, you can see each pod will be having their own network, own IP. See here, you can see the node minikube. See, currently cluster and node are same here. Okay, so when you hosted your cluster in your any of the cloud, either AWS or Azure, because nowadays nobody will keep clusters in locally, they'll host it in your cloud platforms, either Azure, either AWS or GCP, right? In case of AWS, which is ECR, EKS, sorry, EKS, right? And in case of Azure, which is AKS, correct? Elastic Kubernetes Services and Azure Kubernetes Services. EKS and are the services. EKS are the services in from AWS and Azure, which helps to create the platform, Kubernetes platform to host our Kubernetes cluster. Okay, so we'll show the cluster where we create, and you will have to create a cluster. That's it. So in your account, wherever you are using, you can create your EKS and you can connect to that. You can create nodes, pods in your locally, and you can push it to there. That's it. Okay. Now, how do we understood the debug logs of pod, debug logs of deployment, correct? Similarly, we do have the debug logs of service, because there is a way to create your services in Kubernetes. There is also a way to debug that we need to understand clearly, right? Now, how do we get the debug logs? kubectl describe svc followed by the what? Service name, right? We need to point the service name, right? And if I run this, you will see the logs here, because see the name, under the name it is giving the service name, and the service is under which namespace it will give this way. And the labels, see here there are three things: labels, annotations, selectors. Okay, remember we have provided selectors in our YAML service.yaml, which is app is equal to my app. That's why it took selected as app. Means we are tagging it some name. Okay, and the service type as cluster IP, and then IP family policy single stack. This we know what is about this single stack and all. Then IP families IPv4. There are IPv4 and IPv6, right? This comes under networking part. We are currently in IPv4, right? And suppose if you want to migrate from v4 to v6, we'll have to use end-to-end configuration. Okay, now the particular service IP is this. Here you can see the IP of the service. This is assigned by the node, Kubernetes node. And then under IPs, if there are any multiple IPs, if you create any multiple service, it gives here, and the port here, ports and the target port for TCP 80 and 8080 for target port. There are no endpoints because we are not using it for an actual live application. And the internal traffic policy cluster means where we are creating it, where it where the service is created in the cluster only. And then events here we can see none. Why? Because we have not used any the actual application, right? So if we do cat service dot yaml, here it pulls, it's a dummy only, right? The under metadata we do have our cluster IP. Here we are not going to call any Docker image inside the service YML, and it's just a simple way to create the service, the dummy service. Okay, that's why we are not able to see the events. But when you create your service, you should see the events here. Similarly for pod, similarly for deployment. Okay, so that's how we do based on this. If you see events none, you should understand something you're missing. Correct? Correct, right? So you are missing something, right? Now, remember that when we create this, we would have seen the logs, correct? See, as I said, the first portion of under service.yml is for application, but here I did not provided any pod related component. When you are providing this pod component, you will have to provide the image port related to that only, related to your pod, because here is an independent service. This I'm created here. Okay, so whatever the service that you want to create, the first portion you should point it as your pod. Okay, here, and the second portion you will have to define your kind of service, and you will have to provide the same name, the one you created here for a pod. Means it will create a service for a particular pod when you point your specification here. Okay, so this we make use in our Helm charts. We do create pods, deployment service namespaces from the Helm charts. Okay, there are more concepts. Let's learn one by one. Okay, now the service is created. So this is how we do describe the service. And yes, so any questions, guys? Let's do cat here. Any questions?
Sandeep,
You
what
guys are
are
with me?
annotations?
Okay, so annotations and the labels are, okay, let's go to the log. See here, when we use any excuse me, any specific annotations, in the sense we do have API, right? So I was showing here. So if there are any Kubernetes APIs which we wanted to use, these APIs has some annotations, means some symbolic representation to pick the API. That is the case, we do use annotations in the YAML file. If we provide any annotations as a Kubernetes API, it picks up the Kubernetes and gives it here. Means it picks some data kind of annotations. That is the reason we do provide annotations in the YAML. Even similarly for labels and selectors. For Labels, annotations, selectors are the parameters that we're gonna use in the YAML file. If we provide in YAML only, it will print it here. If not, it will not print. Basically, labels, annotations, selector are currently we will keep it as tag, or we are tagging something. We are picking something by providing labels, by providing annotations, by providing selector. Similarly, this way. So called annotations. Clear?
Okay. And in so in our organization, we will
Hmm.
have the limited CIDR blocks, right? Range
Cider block. Okay.
CIDR blocks. Yeah. How
Hmm.
to give that here? Because this IP is auto selected.
Yes. See,
Will
when
it
you
go
have
out of?
okay,
Yeah.
when you have your limited cider blocks, we should be basically your cider block should connect to your cluster so that it will be when it connected to a networking part inside the cider block limit only it assigns the IP within the cluster, because our cluster should be in our network. When you have a limited cider block, it will assign it in a limited way, because we don't want to create a IP address from outside the cider block, right? So cider block gives a table to list of IP within the network, correct? Correct, right? Now, if your cluster you hosted within your network or in your cider block, it gives the IP within the network only. So if you have a limit, we'll have to either based on your application usage or based on the capacity or the size of the cluster, we do increase the IP address. Else, it will assign within this IP which we gonna have the cider block inside the cider block.
Okay.
Yeah.
And sir, here we have for pod we have one IP, separate IP, and for cluster for that service we have one IP, right? Separate IPs we will
Yes.
have.
Yes. Yes.
When we are accessing any application by suppose Nginx or that
Hmm.
we will use access by service IP or a pod IP
No.
from
See,
outside.
when you use from outside, you're saying. See, from outside, currently we do have to create the service called load balancer.
Yeah, even we
So
can't access from our browser also by using this node port by node port service.
see, node port load balancer we can access, but when you use type as cluster IP, we should be accessible within the cluster, right? So that's what I said here,
Yes, yes,
right?
yes.
So which exposes the services in an internal IP. This makes the service accessible within the cluster, right? So here what I have given from inside the cluster to outside the cluster, right? Similarly for load balancer, when you point the node port range between 30 to 32,000, you should be able to access using this node port in
Yes,
your browser. But when you use your cluster IP, you cannot access in your browser. That should be accessible within the cluster. See, if you run your curl here, see you created an application called some any. Okay, so when you do
okay.
curl with this application, you should be able to do, because currently it will not work. Why? Because this is not the actual application. This is not the actual image that we got here, right? So you can do within the cluster curl and you can see the logs. That's it.
Yes, and see, like we are using like some in Jenkins application.
Hmm.
So then, if we don't access this one, then in which case we use this cluster IP? For which cases we use this? Normally, we for accessing any application we develop, right? So this is for only internal communication. So in
Yes.
which cases we use this cluster IP?
Okay. So there is no case that we're gonna use cluster IP. Okay. So when you write your YAML configuration pod, so let's say you started creating a service. Okay. For the cluster IP, we will not mention type as cluster IP. Okay. By default, it will create the cluster IP. You getting my point? There
Okay.
is no scenario that you will have to create type as cluster IP. But why do we create? To access first whatever the application that we build, it should be accessible within the network, right? Within the network in the sense within the cluster. Then how do we make sure? Through this cluster IP only. See, if you're not provide this type as cluster IP, it will create it as a default IP as cluster IP. When you run your kubectl get svc. It will list easily like this when you not provide type as cluster IP. When you are not providing type as cluster IP also, it will create a default service from our YAML configuration. That's what you need to understand. We need to understand the definition here. So it is a default service in Kubernetes. Default in the sense, if you are not provide a type as cluster IP also, somebody is waiting to join. At least they would have called, no? Umar, Amruta, and Sharif, you guys are disconnected.
Yes, sir. We're waiting, sir, in lobby from.
You would have called, no, at least for somebody to tell that, because when we are in a discussion, we will not see the this thing. Okay, when I'm sharing the screen, I'm not able to see this when you are waiting. At least you should call someone and tell, no, at least.
Yes, sir.
Abdullah,
Sir.
instead of pinging in group, you should call and tell, no?
Okay, sir.
So
Next
is that
practice.
useful for you when you pinged in group? So you lost 30-minute session then. It's common sense here. At least you should tell someone to allow. See, when I'm sharing screen, I'm not. Are you able to see when somebody is waiting in the session? Are you able to see this? When I go and check this in chat box only, I can see, okay, somebody is waiting. At least you would have called somebody. You would have called me, no? You have my number.
Yes,
Correct?
sir. Will do.
Then
With text.
no, it's waste. No, it's waste of pointing in group that you're saying you are waiting in lobby from last 30 minutes.
Yes,
It's
sir.
waste only. It is waste for you, not for me. If you're not able to join the session, at least you would have called somebody and tell that hello, because instead of that, you lost 30-minute session then.
Sir, but I
It's a
thought
waste for you only.
it is
What
with
you thought?
everyone
Yeah, you should tell somebody to allow.
because
It
multiple
should
people.
happen. It should happen. You need to understand the concepts, right? When we're in a deep discussion, you should join the session properly. If not, call somebody and ask them to join. Okay. So what I was trying to say here, cluster IP is the default IP in Kubernetes cluster, and there is no particular specific scenario that we want to create. But why do we use this cluster IP as a service? We should be able to access, we should be able to check whether the created application is in accessible in within the cluster as a types cluster IP. Okay, either we do curl with this IP. Okay, we do this way, and we gonna check whether we're able to access this. If not, we gonna use curl with this name. Okay, so curl, we do access this. Okay, so why? Because now it is not working, because this is not the actual application. It's a dummy one, right? So you can pick any of the application, any of the service you do create, you should be able to access using curl with the either you pick IP, either you pick service. So that's how we use the service to be exposed, service to be accessible within the cluster. We use cluster IP. Is it clear, Jairam?
Yes, sir. And I have one more doubt. Like last week, we have created one YAML file with the deployment, right? In that last week, we tried to connect, we have created Nginx part, and we tried to connect that to from our browser. It didn't work. This is the reason? Because we didn't mention the which service we are using. Due to that, it is like default cluster IP, right? In
Yes.
the
Yes, this is the
okay.
reason you are not able to. Did you access in your web Nginx?
No, sir.
See, okay, I got your question. See, when we are using cluster IP as a service, it will be accessible in within the cluster only. It will not be accessible in your browser. Okay,
Sir,
and now when we use type as node port or load balancer, it gives, see, when you use type as load balancer, it gives some external IP, right? and that is the case, you will be able to access your application in your web. Similarly, when we do have created the application service as node port, we'll have to use this gives the node port IP here instead of cluster IP. Through that, you are able to access that application in web. But when you use cluster IP as a service in the cluster, you are not able to access in your browser. Similarly, external name, dedicated domains we should have, right? The fourth type, right? So the external domain in the sense we do purchase from the DNS domain. Through this only we are connecting it by providing a name, and the under spec we do provide service type as external name, and the external name that we're going to point it here is as a DNS that we purchased for this specific uh, application. Through that application only we were able to access. Getting? And
Okay, sir.
even when we use the IP address from the load balancer, it is not also safe, right? And also when we use the node port followed by node port IP followed by the port number, it is also a not safe, right? So when you point your application followed by IP address followed by the port number, you will see not secure, right?
Yes, sir.
Means it will not be secured. We'll have to use the application dedicated domains, right? Like www.whatsapp.com, web app, WhatsApp web app.com, correct?
Yes.
Correct, right? We have to use the dedicated domains application. That's how we controlled using services. We do expose the node port, we do expose the load balancer, but ultimately we should have the external name service purchased with the dedicated domain. Then only we will be able to access. Suppose if you are browsing something in your browser, suppose let's take an example of AWS, right? If you are able to access this US East 1 console.aws.amazon.com is this is the dedicated domain. This domain handled by one of the cluster. This cluster is have some multiple nodes. This multiple has node has some multiple deployment, multiple pods, multiple services which is created backend, right? You getting my point? That's how
Yes,
we
sir.
do make use the external name with a dedicated domain to be purchased. So when they start Amazon.com, these guys, right? They would have purchased this. See how the very first guy built this website, aws.amazon.com, right? The guy who built this website, he has purchased cluster and he has implemented his cluster and he has maintained that infra completely with this domain, right? That's how it works. So when your application is not working, then where you will go to check? You will go check in the cluster, you will log into your node, you will log into your pod and you will check the pod logs and you will get to know, see, suppose if this service is missing, if this service is not able to create the events, right? Suppose if this service is tagged to that particular application saying Nginx or maybe in Jenkins, you will go to the pod specification. Then if you do cat pod.yaml, you will check this and you will fix. Suppose if in very rare case, if your pod is stable, even though when you are getting the error saying maybe the image that you wanted to upgrade it, because we will not upgrade the image every month or every 6 months like that. No, we're gonna upgrade our image might be every 2 year once. If you are getting lagging with this version, you will just upgrade it to 1.14.2, sorry 1.16.2. Then you do deploy this YAML, create the pod. For this created pod you will have to create your services. Getting my point? You're backtracing it. See, if your service is not working, describe your service, check the pod, check the logs. If it is the issue with the pod, you come to your pod YML, pod configuration, check everything, describe pod and check the logs. If the issue with the older version, like some database, some point, some events which is not picking from the older version, you just upgrade it to the newer one, which is 1.16.2, and then do kubectl apply fnf. It will upgrade to 16 the version, your Docker image, and with the container port 80. Then you recreate the service again. Then the issue will be solved. That's how we do debug the pods and services. You were able to understand this.
Yes.
Yeah, that's how we do. Any questions, guys? Anything that you want to understand? So I'm gonna give cat service.yaml, and okay, I have already provided here. And similarly, instead of this type here, cluster IP, we do use the node port range. Okay, so let's create the node port. How do we have? Let's go to vi. Where do we use the node port between the range, as I said, right? Control R vi service.yaml. Okay, now here, so I'll just modify with the same YAML file to the node port. Okay, now I'll keep it as API version v1 as v1 kind service metadata my node port service. I'll keep it here as, instead of cluster IP, I'll keep it as my node port service. Okay, and under spec I'm going to give it as selector app, my app, and then under ports I'm going to give it as protocol. Let's keep it as protocol TCP and the port 80, and the target port is 8080. Here we need to add one more. What is it? What is it?
Node port.
Node port, correct? Node
Yeah.
port. See, only P should be in uppercase, colon. What is the node port range? 30,000 to 32,000. So in between you can point any name. Okay, 30080, any name, any port. Okay, and the type here is we're gonna point, instead of type we point node port. Okay, and let's save this. Okay, so the range 30,000 to 32,767, right? So in between that only we have pointed the node port range. Okay, let's save this. We do cat service.yml yaml. So the node port range 30,080. It is within the limit only. Now if I run kubectl apply -f service.yaml, so service will be created. If you run kubectl get svc, we will get two services, correct? So one is for cluster IP and the other one is for node port. Okay, and also we would be having the node ports here TCP, but when we use node port range 30,080, it will come here. Okay, now when we do this kubectl get svc -o wide, okay, so we'll get the complete wide range of, means it will get one more will get added, selector as a label like this. Okay, and the type, see, don't get confused here. Name, type, cluster IP, and there is also one more called cluster IP. I'll tell you what it is. Okay, and external IP, port, and the age. Okay, now this line represents the parameter that we're going to use in our cluster. Okay, what is the service in your service name in your cluster, which is this, right? And what is the service type in our cluster IP and the node port. What is the cluster IP within the cluster? You were able to understand the statement. What is the cluster IP in our cluster? This is the IP which is for the particular services within the cluster, but this cluster IP is a type within the cluster, type as cluster IP. Okay, you might get this question in the interviews. That is the reason I have created multiple services as a type, cluster IP and the node port, right? You were able to understand this. So this cluster IP is a type of one of the services in your Kubernetes cluster. This cluster IP is the IP address of your services, which is assigned from your Kubernetes node.
Yes, sir.
Getting my
Yes.
point?
Yeah.
Guys, don't get confused. You need to understand this properly. That is the reason we do use this type as cluster IP, type as node port, type as load balancer, type as external name. But this IP, this cluster IP is assigned from your Kubernetes cluster with a particular services. Okay. Now similarly, we do describe this node port. Let's describe this kubectl describe to debug. Okay. Kubectl describe svc, right? Followed by node port IP. Okay. So here you will see under node port we would have this 30,080, right? And similarly the name, namespace, labels, selectors same which we pointed, and the service type which is node port, and the IP this is assigned from the Kubernetes cluster from the node, and the target port is 8080. Here we need the node port. So how do we access this application? When we use type as node port, when you go to your browser, you will be able to access this application with the node port range. How to access? So this will not gonna work out. Our service type followed by what is our node port IP. This is how we do access our application. Getting my point? Because this will not gonna work out because here we do have the dummy application. If you use the actual application, you will be able to see this in your browser. You will have to use your node port to access, because we're exposing our application using node port range, right? Between 30,000 to 32,000. That's how it'll make use from the networking part. It will open a port of this particularly, and we can able to access. And even though this will not be a safer side when we're accessing our application with the node port, right? So when you access it, you will see the not secured. Getting my point?
Yes, sir.
Cat service.yaml. Any questions, guys? Type as node port. So I'm gonna share this in the group. So can you also create type as load balancer and type as load balancer and the external name? Can you work on this? And after doing this, can you create the services for the actual application?
Sure,
And
sir.
can you try accessing the application within the cluster, and using node port you will have to access from the browser and the load balancer and the external name. Can you guys do this? I have to keep it for charging.
Yes, sir.
Can you do this?
Yeah.
Okay, so if that is the case, I'm gonna give an assignment today, so let's work on that. Okay, so I'll share this in the group, and also the command that have ran here. Let's run the history here. History, you will see all the commands. Okay, when you history is a command where you will see all the commands that you ran. Okay, now apply service.yml, and okay, I'll share this in the group. Okay, any questions, guys? Anything that you want to understand? Anybody has any doubts? Guys, I'm asking you only. Sharif,
Sandeep, if
yes.
we are using
No, sir.
node port,
Good, sir.
What is your question, Amrita?
if we are using node port,
Hmm.
still we have to use a target port 8080 because
Yes.
the node port only will use inside and outside both, right?
Yes. See, no. Wait. See, when we wanted to use node port, we'll have to expose our application to the web via the node port as a service from Kubernetes cluster. Okay, so when you are able to access via the port 8080, then fair enough, but this will not be always be available, because if anybody picks the port 8080, we should not be have the dedicated port. That is the reason we do have the node port service from cluster and the range between 30,000 to 32,000. So that is the reason we use node port. We are exposing application via one of the service called node port and the range between 30,000 to 32,000. Correct? Is that
Yes.
clear?
Yeah.
Okay. As we see -o wide, and also I'll give the node port range between 30, because I have already shared this. I might miss when I'm sharing in a group. Okay, the node port range. Okay, I'll give it here. Okay, so if not having any questions, let's wind up the sessions, and I'm going to give some of the assignment. You guys have to complete it before the tomorrow session. Okay, so who are all there today? Sharif, Abdullah, and Niharika. Any questions?
No, sir.
What is it? External IP? Okay. So when you use service type as load balancer, okay, let's show that also. So external IP. See, when you are using your service type as load balancer, then only you will get your external IP. Okay. So now if I run kubectl get svc -o wide. Okay. Now here we could see all the services that we created, which is cluster IP and the node port, right? Your question is when we will get external IP, right? When we use the service type as load balancer only, we'll get external IP. Okay, let's work it here. Let's create a service type as load balancer. Okay, vi service.yaml. I'll just modify in the same YAML. I'll keep it API version v1 kind service metadata name. Okay, under name I'm gonna give it here as load balance, my load balancer -service. Okay, load balancer -service, and then under spec I'm going to give it selector and then app, my app, ports protocol TCP port 80, and then target port 8080, and here I'm going to remove this what node port range, correct? And under type I'm going to give it here what load balancer. Okay, so let's save this. Okay, now see, remember this output will not be having any external IP for these two services. Okay, so what I'm going to do, apply kubectl apply -f service.yaml. Okay, now the load balancer service is created, right? Now if I run kubectl get svc -o wide, what it is saying, external IP, it will create it, but for what? Service type as load balancer, correct? So this will take some time to give it as an external IP. This will take some time. If you rerun the same command again, it will be created. Still it is pending. The service, the external IP is pending, right? Correct, right? It is trying to assign. Now, once this assigned, you will get the external IP for this as a type load balancer. Yes, this will create automatically. Did we point it anywhere the node port range? At service.yaml. This will create automatically. because the TCP protocol that we used with the same config, right? So that's why it picks the default one, which is the available port within the system. Yes, what is your question? Yes, see, always whatever the service, see this cluster IP which is assigned for this service, okay? For this cluster IP, when we use load balancer as a type, it gives an external IP, and rest of the services will not get any external IP for cluster IP, node port, and then external name. For each and every service, it gives the cluster IP here. And services type cluster IP also has their own cluster IP. You getting my point? Yes. Yes. Anybody has any questions? Let's run it again. Let's see if this assigned or not. See, it is still pending, but it will assign some IP when you use only the service type as load balancer. Okay. Yes, you can. You should be able to access your application via this external IP only. That's what I said. So if you use actual application here in your service YAML configuration, you should be able to access using your external IP. And similarly, when you use your node port followed by your application name followed by the node port range of 30,080, you should be able to access your application in web. That is how we do expose our application using our Kubernetes services and cluster IP within the cluster. Similarly, when we have a type of external name, I'll also show that. Okay, so type as external name. So what I'll do, I'll just modify this service.yaml and kind service metadata. Let's keep it same. Under metadata, let's keep it as external name. Okay. Instead of load balancer, I'll keep it as external name. External name service, and this under spec, I'll just give it as type as external name. So what I'll do, I'll remove everything. Okay, type, I'm gonna give it as external name here. External, external name, and just a minute, external name as, here we should point our DNS. Okay, so instead of this sample.com, we should have our dedicated domain is purchased in the, for this particular application, we would point this through that website, through that DNS, we would be able to expose our application using type as external name. Okay, now let's save this. Let's do apply. Okay, now this external IP is created, service is created. When you run kubectl get svc-o white, it will list all the services, all the 4 services, which is the service type as cluster IP and then external name. Here you can see under external IP, it will reflect as your website, right? Website in the sense the domain that you purchased. Through this domain only, we should be able to access our application. Similarly, when we use your load balancer as type, we would be able to access this external IP in our browser. So when you use node port as service type, you should be able to access your application, the node followed by the node port, which is 30,080. The service name or the application name colon followed by your node port range. Clear? Is
And
that
sir,
clear?
is this load balancer means we need to link with the AWS? Like load balancer means then only I think it will.
No. Wait. This your Kubernetes service type as load balancer is different. Your AWS load balancer is different. Here you're using service type as load balancer in your within the cluster, but in your Kubernetes cluster, in your AWS cloud, you will be having load balancers are separately, right? That is different, and this is different. But when we build our application, we should be exposed it to the web, right? That is the reason we use in Kubernetes as a load balancer, as a service type. But in your cloud, you will maintain all the traffic out of your cluster, out of your images, out of your networking part, right? Correct, right? Content of request is different in your cluster and in your complete cloud. Clear?
Okay, sir.
Clear or confused?
Yes, sir, clear. I thought it will come this IP, external IP, when we tagged our this cluster with our AWS with configuring with the either application load balancer or network load balancer. Then only I thought it will come this external IP. Okay, then I understand it is different completely.
Yes. So try enabling it if you're, because see these are all the dummy services. That's why we're not getting any external IP here. When you use the actual IP, you will be able to access it. Okay. There are applications, there are some codes are available, right? If you refer some Docker document or maybe in Kubernetes document, you will get one application for a particular Docker container. You create a cluster IP with the same code, create a load balancer with the same, create a node port with the same, and you should be able to access the same application with the IP and the sample external name and the node port. Can you guys do that? I will show where you will get. If you can open Docker, because it is open source, anybody can get this Docker documents, sample application for Docker. Okay. Mm. There is an see here, you have an application. See, when you access this, you will just see this. Okay, just if you click on add item, you will gonna add it here. Okay, so this is a sample application. You can work on this. Okay, can you create for this application for a pod and create service? Can you create all 4 services for this? So this is an application. Okay,
Using
will
Kubernetes, right?
yes, using
Okay.
Kubernetes.
Okay.
So you have your application called getting started app repository, because I use this application for my one of my R&D project. I have given a demo and I used it. This is open source. Okay, anybody can use this. So as soon as you run this command, it will come to your repository as a getting started. Inside this, you will have this folder structure, and if you want to build this image as a getting started app, just you run it. Cd, go to this path, follow this instruction. So when you run docker build t, you will have container get created. You can use the same container in when you are in creating a pod. Okay, you will have to run this container, and you will see when you access in your browser, you will see this page. Okay, so you can do docker ps. If you run docker ps, you will see this application called getting started, and after creating this image, same you can use it in your pod creation, deployment creation, service creation. Can you guys do this?
If possible, can you share that link once?
Yes, definitely. I'll share this. I'll keep it in notes because it's open source. Nobody can hide this. Okay.
Okay.
So sample application. Okay. This is from the Docker document only. So as I said, always you should prefer the original documents. Suppose if you are working in Jenkins, follow the original documents. Okay. This way, Jenkins documents. If you run this, you will have the Jenkins origin. See, follow this .io. Similarly, you will have all your documents here, right? So this is the document. This document to be validated from the platform team from your project in your organization, then we'll start using it. Similarly, we should have our Git, right? When you want to know Git document, right? So you will always use Git SCM document this way. So you will get everything here. Okay. So either if you want to know any command, there is a complete manual will be available. And similarly for what? For JFrog, right? JFrog Artifactory. Here is the document for each and every. Here, if you go here, if you can, so somewhere you will see the document, right? Resources, under resources are maybe documentation, right? So you can follow, you will see all your JFrog CLI, and similarly for, so you can refer some of the documents, right, with the original tools that we're gonna configure, correct? So this is how you can work on this. Clear?
Yes, sir. Clear.
Okay. So I'll share this in the group. Let's connect tomorrow.
Okay, sure.
But when you are referring this document, if you are in a position to understand, then fine. Else, at least you should contact somebody. You should get some updates. Okay. Thank you. We'll connect tomorrow. Bye-bye.
Thank you, sir. Bye.